two is that we're going to talk about temperature. Temperature and pressure. So according to the ideal gas law, we see that the gas law tells us that the gas pressure is then going to be proportional to the number of molecules this time it's going to be the temperature of the gas divided, of course, by the volume. And so all we're focusing now is what? On temperature of the gas. And remember what we said about temperature earlier. What we said about temperature here is that it's about the average kinetic energy. So if it's about the average kinetic energy, then that's what we really got to pay attention to here. So let's go do that. And so what we find here is that when we do this, what do we actually see here? Let me go in and try to find my thing here. So you're seeing my thing here. So when I go and I look at this guy, what I'm seeing here is that, again, temperature is the average kinetic energy of the molecules. And what you're going to find here is that how do you add heat now? And so the way we add heat is that we go in and we start to increase, right? We start to increase the system here. So let's go look at this thing. So what I'm going to do here is that I'm going to try to increase this thing to a temperature of, let's say, 300 K. So look at the temperature here. So what I think I'm going to do is I'm going to leave the number of molecules, which is around 250. So now here's what we're going to do. I'm going to add heat. So as I add heat, I'm going to increase this temperature, let's say, to 300 K. A nice number. So now look at the gas pressure. And you know what? I think I'm going to add some more particles just to get a nice picture here. So look at the kinetic energy of these gas particles right here. Okay, look at the speed. Now what I'm going to do here is that I'm going to reduce the temperature. And the way we reduce the temperature here is that I'm going to go in and I'm going to, as we say here, we're going to ice it. So now, look, this is going to be cold here. So I'm going to try to reduce this down to about 100K, 95K. So here we go. Look at the average speed of the molecules. See how they're much slower? That's the temperature. So if I continue to do this, you could see that now I'm just kind of exaggerating this thing, right? They're moving nice and slow. So if they're moving slow, note that there's less collisions with the walls. So therefore, the pressure has to be lower. If I have more collisions with the walls, then the pressure has to be higher. And that's what we mean by temperature here. So what I'm going to do here is that I took some screenshots and then I want to come in and share them with you on my screen here. So let me go back to my OneNote. And so with my OneNote here, so we started looking at this, and one of the things that we said here is that the thing that we find here is this, is that, so the thing here is that if let me go get the images just to be nice and clear. Let me grab the image. So if you look at this guy here, here's, oh, damn. Gotta have my mouse here. Okay, there's this guy. And then I have one more. And then there's this guy here. And so what we're really looking at in this case, I lost my mouse. Here we go. So what am I seeing between these two cases here? So the first thing that you're seeing here is that there's a couple things that you want to pay attention to. Look at this guy right here. Look at this guy. And if you look at the pressure, look at the pressure here. Look at the pressure here. So you could see in this region, this creates a high pressure with the high temperature. This creates a low pressure with a low temperature. So what you're seeing here is that this is what we're actually seeing. So what we're saying here is that we're saying this. So if I look at what I just did with the applet, is that if I add heat energy, right? And what I mean here is that when I say I add heat energy, what I'm really doing is that I'm increasing kinetic energies of the gas particles. So if I do that, what does that mean? Well, I now have more collisions. Why are there more collisions? There's more collisions because now what are they doing? They're moving faster. So if they're moving faster, they're going to have more collisions with the walls. And as a consequence, we then have a higher pressure. However, if we remove heat energy, we're not increasing kinetic energy, we're decreasing kinetic energy. And if we decrease kinetic energy, then the molecules, because they're moving slower, have less collisions, right? And therefore, this creates a lower pressure. So we're always asking the same kind of question, right? We're always asking the same kind of question. When we're talking about the ideal gas law and atmospheric pressure, we're going to ask, what causes the low pressure region? The only way you can do this here is that you got to do what? You must remove heat energy. And if you remove heat energy, it simultaneously reduces temperature. So somehow you have to reduce temperature.